Assalamualaikum and salam sejahtera to IR Dr. Chua Binti as my lecturer for Finite Element Method subject. My name is Nuraina Alwani binti Muhammad, metric number BK18110162. Today, I would like to present my assignment 2 as required by doing PowerPoint presentation. This assignment is divided into two parts, which is part 1 and part 2. First and foremost, in part 1, the requirement is to compare the free end deflection and largest principal stress for CTS and Q4 element method. So, for this part, the information given is the load, which is 2000 Newton, length 0.1 meter, height 0.02 meter, thickness 0.005 meter, and Young modulus 200 gigapascal. However, for portion ratio, I do search it based on the basic beam portion ratio, which is 0.32. Next, before I do the analysis, calculating the theoretical calculation for the inertia, bending moment section module, maximum stress and the deflection is necessary, as in the end letter I can use it to compare with the analysis using FEA software. For the calculation, the moment inertia obtained is 3.333 times 10 to the power negative 9 meter to the power 4. The maximum bending moment is 200 Newton meter. For section module, obtained is 3.333 times 10 to the power negative 3 meter cube. Maximum bending stress is 600 megapascal, and the free end deflection stress is 1.00 times to the power negative 3 meter. Secondly, this is the free body diagram for the beam, including the mesh and constraint for Q4 and CST element model. Firstly, for Q4 2 row 10 column, and then CST 2 row 10 column type 1, and CST 2 row 10 column type 2. And lastly, for CST 2 row 10 column type 3. As shown, we can see that the beam is meshed different from each other, and from this we can determine how the mesh will influence the stress on the beam when the load is putting on it. Next, the slide shows the analysis of beam using FEA software. For example, the analysis on Q4 element model. And from this analysis, the percentage error was calculated to determine how much error occur for every each of element model, and all of the calculation was done using the same formula and the same theoretical value which have been calculated before. For this element model, which is Q4, the percentage error for the displacement in y-axis obtained is 8.85%. For the percentage error occur at this for stress x obtained by using the same formula is 8.67%. The analysis also has been done on the other three types of element model, and this is for CST type 1 mesh. Thus, the result of the analysis is shown in table form. From this table, the comparison between free end displacement stress and the largest principal stresses for CST and Q4 element models. Furthermore, we can see that the number of nodes and number of degree of freedom obtained is same as the beam constructed using the same dimension. However, the free end displacement stress and stress SS value for all plane element is quite different. hence resulting in different percentage error obtained. For instance, from the table, the highest feed and displacement obtained and the largest principal stress are produced by Q4 element model. However, there are quite large difference between percentage error using Q4 element and CST element, where we can say that the analysis using Q4 is quite precise with the theoretical calculation, which produce the lowest percentage error than using CST element, where the percentage error is quite big. Furthermore, we can go to part 2, which the requirement is to using mesh by applying symmetry condition on the beam. In problem 7.4a, to obtain the highest stress values, the analysis was done by constructing the FBD in FEA software, which is LISA. And since the detailed information is not given, I assume that the load, Young modulus, Poisson ratio and thickness value is same as the previous part because it apply on a beam. So I assume that the detail is same. Then the analysis result for the stress is obtained. Moreover, based on the stress x-axis, the highest stress occur at the bottom corner at the end of the beam when the force is applied. For stress at YY, most of the feed surface have the highest stress because when the load is applied, the beam will undergo stretch force due to the feed surface of the beam. Finally, the von Mises stress. The highest stress occur at the upper corner at the end of the beam, which when the force is applied, the beam kinda turn to a bending as the upper corner is set as the fixed surface. Therefore, the highest stress occur there. Therefore, that's all for my presentation. Thank you for your attention.